Morning. What we're looking at today is the extrema of this function. All right, so in order to find the extrema, what we want to do is we're going to take the first derivative of this function. Let's go. So now that we have the first derivative, at every extrema, the derivative is equal to 0. So let us do that. At our extrema, the x values are positive and negative 2. So now we're going to test the region to see where exactly do we have the maximum or the minimum. Let's go. So here on the number line, we're going to test values that are actually between these markers that we have. So I'm going to find a value when x is equal to 0, because 0 is between this. I'm going to use when x is equal to 3, because 3 is outside here. And I'm going to use when x is equal to a negative 3, because negative 3 would have been in this section here. So 3 testing points, because we want to know whether they're maximum or minimum. Mark you, I'm going to test if they're maximum, if this is happening. Now, if this is my marker, and if to the left I got a positive, it means that the slope is this way. And then if to the right of it I get a negative, so this would be a positive, this would be a negative. It's going to tell me that I'm at a maximum here. And if this is a negative here, and then I get a positive next, then I'm at a minimum. So I'm looking for that. So let us test to see what happens. So now we're going to take the derivative function, which was actually, so we're going to do, so we're going to substitute negative 3 in our derivative function. Our derivative function actually was 3x squared minus 12. Putting our negative 3 there. So let us put it together. So this is 3. This is going to be 9 minus 12. So this is 27 minus 12. And this is actually positive 15. I don't really need the value. I just want to know if it is positive or negative. So what this is suggesting that we're positive here, right? We're positive there. So that means we have a line like this going up, right? So let us test between now. So all we're going to do now is to test 0. So now I'm going to plug 0 in this, right? So 0 here, here. And let's see what we have now. This becomes 0, and then we're left with negative 12. That means we have a negative here. So you could see now that at negative 2, we're at a maximum, right? Right here is maximum, because we got this and then this, positive and negative, okay? So we're at a maximum right there. Now let us test where 3 is to see what's going on. So in my derivative function here, I'm gonna plug in 3. Let's do that. So this is gonna give me 27 and then minus, right? So 27 minus 12, and this is a positive 15, right? So this is positive here again. So if you could take a look at what goes on at positive 2 here. Now this was a negative to its left, that means we had this, and then a positive to its right, that means we had that. So you could see that this at negative 2 was a minimum. So we're definitely seeing here that the extremas that we have, we actually have a maximum at x equal to negative 2. This is a max that we got. And at x equal to positive 2, we actually had a minimum right there, right? So there it is, and that is how you could quickly find your max or your minimum based on this method. Thank you for watching DellyMaths Concepts. See you next time. Bye-bye.